Thank you. Thank you all for being here. I'm going to be talking about, as Purnima said, why you should do text analysis in Python, even if you don't want to. That's my name over there, in case anyone's interested, and I'm going to start. Cool. Why text analysis? I mean, the talk is called Why You Should Do Text Analysis in Python. So I'm going to be talking a little bit about text analysis in general, kind of get you all into a feel of what it is and why it could possibly be interesting, and then move on to why Python's a cool and fun choice to do this. So personally, I mean, you can kind of think of text analysis as data analysis, but your data is just text, right? And sure, it's cool. You can get jobs out of it, which is pretty neat. It's also fun to do. But what I personally found very interesting about text analysis was the fact that the data seemed more personal. That's where I started. I mean, I felt that it wasn't to find something interesting or predict something. I was like, whoa, this is just really personal data. And it started off actually with this messaging app called WhatsApp. I'm not sure how super popular it is in America, but back in Asia and Europe, it is very popular. Me and my buddies, we were all on WhatsApp, and we had a WhatsApp group which is like 6 or 7 years long, right? Because it's like 2010-ish. And at one point I figured out, wow, if I have access to all of this just textual data, all of this texting I've been doing with my buddies, could I possibly do something fun with it? So I just broke it up like year by year, and so you can also totally download all of your WhatsApp message data. You click on your group chat, and then you do like send email to, and you can email yourself your entire like chat history, right? And you can do this with Facebook also, I think Messenger, I'm not 100% sure, but I know you can do it with WhatsApp. And I did this, and I broke up every single year, right? Like 2010, 11, so on and so forth, and I started running some basic text analysis stuff like who's talking the most? Who's starting the most conversations on groups? Who's doing the most emojis? What are people talking like? And then I started looking, how do we find what people talk about? Then I found about things called topic models, which allow you to actually find out topics in text. And it was cool. Like in the summer during the World Cup, like the soccer World Cup, the FIFA Football World Cup, we were talking about football a bit more. And there was this rough summer when we all kind of got out of relationships and were talking about girls and stuff like that. And it was cool to kind of see how every year we'd be talking about different things and how this would go, who'd start the most conversations. Then we started traveling and moving around, so we had different time zones. So that kind of changed the dynamics as well. And this was what actually got me started. And this was all just with Python and text files, which I mailed to myself. And I was like, wow, this is cool. This is really neat. I'm able to find out things about the way I talk with my friends and the kind of words I use, just using simple Python scripts. And then I started getting more into it and contributing to open source. And this is how it started. But then I realized there's a lot of cool things. When I talked about the personal, how it could be very personal, for example, you can do all kinds of cool research. I really like to read, and at one point we were doing plays, and so there's been Shakespeare. And then I was trying to find out more about text analysis with Shakespeare, right? And apparently, this was done by a bunch of folks over at UPenn, right? I believe, though, don't quote me on that. But they were trying to find out about other authors who could have possibly co-authored with Shakespeare. And this has been a research problem, a research statement in the study of Shakespeare for a long time. Who could have been, like, people were like, Shakespeare's not even real and all a bunch of crazy stuff. But then there was a strong possibility that someone else is actually writing with Shakespeare, right? And they found out, I think, for a bunch of the plays, I think it was Henry VII and VIII, and they found out that the writing style was very similar to Christopher Marlowe, who was another writer in the same era, who did another playwright. And the way they did this was actually by building these, what they call author style graphs or network graphs, where they try to figure out the kind of articles which these authors were using, playwrights were using at different times, and the kind of words, the frequency of words, and just the style of writing. And they found out with they could give, we have a really strong hunch it's Christopher. And then after that, they had actual literary critics who were like, wow, you're probably right. And they had these really neat style graphs. So you could do research in English literature with text analysis. You could do a lot, and this is another story which I normally like to talk about. It's not super fun, but this was back in 2016, 17, right? This was when, I think it was right before the 2016 American election. So Trump was tweeting a lot, Donald Trump. And what was an interesting research project, or just trying to figure out what was going on, was when is Trump actually using his own phone and tweeting? And when is he using, or when is his PR team doing it for him? When is it an agency actually doing these tweets for him? And what was really cool was, so Trump used to tweet, like this is back in 2016, right, just for a bit of context, so he wasn't tweeting with the same ferocity as he was now, but it was still pretty cool because he was also tweeting from a Samsung Galaxy phone, right? So he was tweeting from a Samsung Galaxy phone, but there was also a whole bunch of iPhone tweets going on as well. And these were super nice tweets, like, thanks for coming by to the rally, and let's make America great, all positive stuff. But when he was tweeting with this Galaxy phone, right, he was just yelling, there were caps, and there's all sorts of things going on. And there were other cool things as well. When Trump normally retweets, he doesn't like retweet using the button. He used to go old school. He used to like do RT and then like get the quotation marks in and like tweet like that. So, and these were with a whole bunch of Galaxy tweets. And people are like trying to find out a pattern. You could do like sentiment analysis, which I'll be talking about in a bit. So they used to do sentiment analysis, which is a kind of way of identifying sentiment in text, right? To figure out when is it Trump actually tweeting himself or someone else is doing it for him. And there were other really cool things. This is all text analysis, by the way. You can get tweets off the internet really easy, and you can run basic Python tweet analysis programs to figure this out. They also found out that he wouldn't post links or images much. That was always his like PR team who was handling that. So he'd just post text, usually angry text, but mostly text. And it got even more interesting. At one point, they couldn't figure out, like all the people doing this text analysis weren't sure, is it actually him doing it or not? And then they found there's someone who's trying to ghostwrite as Trump, which would try to use the same kind of words and style, but not be as angry, so you could actually figure it out. And this is really a nice blog post which goes into the details, and you could actually do this for yourself. By the way, now Trump's got himself an iPhone, so it's a bit more difficult ever since he got into presidential office, but this was before he became the president, right? So this is another way you could do political science analysis, so to say, or sociological analysis, just using super simple Python and web scraping and text analysis. So when I usually say why text analysis, you could pretty much do any kind of textual data. You've also got your own email data. You've got whatever kind of data. If you like a certain kind of book or something, you could pretty much analyze any kind of textual data. It has the potential to be personal, so to say, and be kind of like a pet project where you're learning something cool and you're also fiddling around and you can write up a nice blog post. It was just a lot of fun. And I think that is a huge motivation, at least for me, and why I usually like to tell people why I do text analysis. But apart from that, of course, you also have more practical things, right? Like, for example, even a spam, not spam email filter is also text analysis. It's machine learning in text, trying to figure out if something is spam or not. So there's a huge business side application to this. You've got chatbots, you've got a whole world of things which you can possibly do with text analysis. So this is a part of the talk where I try to say, you should really check out text analysis. It is very, very neat. And that's kind of that part of the motivation. I'll be moving on now to, well, why Python? Well, why Python? I mean, of course, this is PyData, and I'm sure a lot of people here know why you should use Python. But I would argue is the best reason is because it's a really good text scraping language. Like, people used Perl before this for text scraping, or just writing scripts for scripting language. But Python's really holding its own now. It is arguably the best scripting language or quick scripting language which we can use, which just makes it really good to just work with text. And not just that, when it comes to, for example, deep learning or things like that, you've got TensorFlow and other, really, it's a very, very strong ecosystem. I don't really need to sell the ecosystem to all of you folks because you would all be aware of how powerful Python is in this context. But for text analysis, especially when you're comparing with other R, for example, most people would probably have like, oh, should I use R or Python to do this? In this case, I think Python really wins because for text analysis, it's great. There's also a lot of libraries which are really, really good for text analysis. You've got industry-grade libraries, which again, I will be talking about a bit more, not just saying they exist, but they do exist. And so it's a combination of the fact there's a really good ecosystem, especially the whole NumFOCUS stack and the PyData stack in general is really, really useful. And you have, things like scikit-learn when you look into text classification, Keras, all of these things, GenSim, which I'm also really, really big fan of. All of these are really, really nifty tools, which are all really easy to use in Python. I'm not saying that other programming languages don't have these, they do, but the ecosystem just ties up really well in Python. Also, if any of you have any questions, feel free to interrupt me in between. Put your hands up. There's no problem. Cool. The next part is, where is the data? I've already kind of talked about that, I think, when I talked about all the data sources and 3 examples. Like, I've talked about Twitter before and my own personal messages. And of course, you have books, which you all legally bought. So you have a whole bunch of really cool data sources. But you can go one step further and look for really structured data on the internet. One of my personal favorite sources is Reddit. I spend too much time on Reddit, but apart from just my personal time I spend on Reddit, it has so just for some context, Reddit is a news boarding website where people post articles based on their interests. So you have subreddits for politics, sports, all kinds of sports. It gets really into, you can have really obscure niche subreddits as well. Food, traveling, there's a whole bunch of it. But the reason I'm talking about is it's largely textual. I mean, you do have images with just a whole bunch of memes, but there's a large textual component to Reddit. And it's also question-answered based, right? What this means is that you can just kind of scrap this and you can model how people talk to each other really well. You have timestamps also in a really neat JSON format. I mean, this is just one example, right? Reddit is just one example. You also have Twitter and you have Facebook. If you so like to use it, you have blog posts. You can also literally just scrape the internet. There are tools like Beautiful Soup which allow you to actually go and clean HTML files, and you can use Python again as an engine for scraping the internet. The internet is literally the most massive text resource you have. Now you have all of these kind of more, what I've just talked about so far is like real data sources, right? In the sense of people talking and sharing, and you can model human behavior. But you can also, like I said before, like downloading books, but it's not just books which you can text analyze. There are text classification and clustering data sets. There are large, like a huge part of machine learning and text, I mean, machine learning in general is just textual analysis. There are a lot of data sets available on any website, like even Kaggle has a whole bunch of text analysis one. Things like sentiment analysis, movie review analysis, there are a lot of already curated, clean data sets where you don't have to get your hands dirty. But if you do want to get your hands dirty, there's a lot of textual data. It's probably an abundance of it. There's just nearly not enough time to analyze all of it. But what's really cool is it's really, really easy to find this textual data. I'm sure even on just like on your laptops, you would have some kind of textual data and text files just around there. And it's really easy to get this. So this is what I think when I talk about where the data is, unlike other cases, other more traditional machine learning, like I'm going to throw this really cool Bayesian neural network or something. You don't know what exactly you are analyzing, right? It doesn't feel very, but I think textual data kind of breaks this, and this is what I really enjoy about it. Pre-processing. Now, so far I've just kind of very generally been talking about text analysis and Python and about why I think it's exciting. But now I'm going to go into a little more details about some of the problems you encounter when you do textual data analysis and what you have to be careful about. So, I mean, most people would have heard of the garbage in, garbage out kind of thing, right? Where if you're going to give really bad data, you're going to get really bad results. And I think text analysis in particular, this ends up happening a lot. And pre-processing is the most important part of text analysis. I mean, it's probably the most important part of any kind of data analysis you are doing, but it becomes even more important in textual analysis because, especially based on the context. I'll give you an example. If you're talking about topic models, which I briefly brought up before, right? So I'm going to talk a little bit about what exactly these topic models are. So they are probabilistic graphical models. I mean, that's like the math science-y description for them. But what these probabilistic graphical models do, which is really cool, is if you have lots of unstructured textual data, let's think if you work for a newspaper agency, you have a whole bunch of newspapers like in digital format, and you want to kind of figure out what these newspapers are about, like 2000, 2014 or whatever. And you can use topic modeling and say 5 topics, like you expect to see 5 topics, and this machine learning algorithm will go through your textual data and come out with 5 distributional words, which are topics. So you'd get like sports, politics, weather, with no input, right? You're just giving in your raw textual data. Now the thing is, if this data is not cleaned properly, you're going to have a whole topic which will be with just pronouns, which are completely useless. These would be a topic, or there'd be a lot of numbers where these things may not be really important and not add any information. But in some cases, this might be really important. If you're trying to model a bot, for example, to do a chatbot, you'd want it to know about pronouns, right? I mean, so based on your context, your pre-processing is going to be very different. And this is a very important part of text analysis. So you have a lot of packages which spend a lot of time to just focus on the pre-processing part or the text cleaning part. And I'm going to, again, also talk very briefly about that. I've not been saying a lot that I will be talking, but I promise I will be getting there. So that's a little bit about pre-processing. I know this is important in all kinds of all kinds of data analysis, but I think it becomes very, very crucial in text analysis. A brief point, all these things which I will also talking about over here, I cover in more detail with a lot of code in a tutorial. I did this tutorial yesterday, which you will be able to see the video of, and I will be giving links as well. So what I would like to say is right now, you would not need to worry too much about library names or particulars. I just want to get you a feel of what exactly this field is. And for the details, like what code you want to be running, how you're going to be doing it, and all the textual data scraping, all of that, there are tutorials which I've written, which I will link to you, or you can just watch them on YouTube after this. This is just for some context before I go on, because there will be more talk about libraries or code coming up. Yeah, so machine learning in text. So all of the things I've talked about before, like including topic models, they're technically a machine learning algorithms which are based on text, right? And you have a lot of libraries which are doing this. Scikit-learn, I think, is probably the most popular machine learning library, at least for your more vanilla machine learning. And Scikit-learn does have topic modeling, and it does have text classification. I talked earlier about where text classification might be in handy, like the spam, not spam thing is probably a very popular example of machine learning in text. It's a very classic example. There's this algorithm called Gaussian naive Bayes, which kind of figures out what words appear more often in a certain context and decides if it's in that class or not. For example, in the context of spam or not spam, you would have like words like offer, money, massive, or whatever, and you'd have these kind of words, and it'd be like, yeah, that's probably spam. And then you'd have a bunch of other words which are probably not spam. So based on what words tend to appear in spammy mails and whatnot, you will be building your classifier. This is a machine learning model. I've said in a really, really simple manner. It's not this simple. There's a bit more, it's a probabilistic model, so it figures out what are the odds of this word being here or not, and it does it. So this is machine learning in text, right? This is an example of how you do it. And these algorithms, and this was a long time ago. I mean, you've had spam filters around for a long while. Things are getting a lot more sophisticated now. So when I talked about, for example, you have tier text completion as well, which is another example of how you have machine learning in text, predictive capacities in models specifically for text. So there's a whole bunch, and all of these, the best part about this is all of this is available, again, in the PyData stack, right? All of your Bayesian models, if you're using PyMC3 to predict something, or if you're just building a simple classifier with scikit-learn, all of these exist in Python. It's very easy to do this as well. This is so these are word embeddings, what you have written over there, and I'm going to talk a little bit about word embeddings. It kind of builds on to what I've talked about earlier about machine learning in text, right? So word embeddings are a kind of machine learning in text. Word embeddings, so a huge problem in text analysis, right, is that we keep losing context. Now, why does this happen? When for example, I gave you the example of the whole spam, not spam thing, right? So what's kind of going on under the hood is we're counting how many words appear in documents. So if you have like prize, lottery, whatever, appearing in the same mail, you're counting these words and you're like, oh, this is probably going to go to spam. But context is important. When we're human beings, we don't just count the occurrences of words which people say to you. You understand them based on the words around them, right? That's a very important part of this. So most machine learning algorithms until a certain time, like early 2010s, they lack this contextual understanding. I mean, there were attempts to try and understand it by looking at, what words are appearing around what kind of words, and you're going there. It's not like it's completely contextless, but it was kind of poor. But then there was this really neat machine learning algorithm called word2vec, which came out in 2013, I believe, or was it 15? I think 13, by these folks over at Google, and it was really, really neat. What it did was it tried to give an understanding, a contextual understanding to what words are. Now, for you to understand why this is really cool, I have to briefly talk about how computers themselves understand text. The way computers understand text is not just through words, right? It has no understanding of what words are. It only knows what numbers are. So what you do when you're building these kind of machine learning algorithms is you map every word to a number, and then you kind of give these numbers to the computer, and then it understands or makes these models based on the numbers. And these numbers are represented as vectors. They're vectors because they're a mathematical construct which tell you whether certain words appear in a certain document or not, and then you make decisions based on this. Now, what word2vec did was, it's basically word2vec or word2vector. So it created a vectorial understanding of words in a vector space. So it transformed words from just being a word to a vector, to like a mathematical quantity. So what does this mean? When we talk with context, this is a really popular example, which you'd find on most blogs or most articles about Word2Vec, but I'm going to do the same example anyway, because I think it's a really nice example to explain why Word2Vec is so cool. So when we have like a contextual or semantic understanding of words, for example, if we say, what is this understanding of the word king, right, minus man plus woman? So you have like this abstract idea what a king is, and then you know what man and woman is, your abstract ideas of it. So if you'd actually do this kind of math, so to say, like king minus man plus woman, you'd probably have an intuition that it's probably queen, right? Like you're taking the royalty part is the king thing, and then you take the man out, you put the woman in, you'd guess it's queen. Now, the super neat thing is when the folks at Google made Word2Vec, and then they basically converted the word vector for king, the word vector for man, and the word vector for woman, and they basically did this math. So they're like Word2Vec of king minus Word2Vec of man plus Word2Vec of woman. The new vector they got was closest to the word vector for queen. So these are computers or machine learning algorithms now being able to understand context like this, which I think is really, really incredible. And this was also a while ago, right? Around 5 years ago. You can only imagine things have been getting a lot cooler in this particular, there's things like fast text and LDA2Vec, which is like a topic modeling on vectors. Basically, things are going crazy in this particular field of understanding context with machine learning. And we can build a lot more powerful models based on this. I'm going to now briefly talk about, or not briefly, I can talk a bit more actually, about computational linguistics. This is a really cool part of machine learning and computer science as well when it comes to language. The traditional study of linguistics, for example, would be, if you look at a sentence, you want to identify the parts of speech, right? You want to figure out what's a noun, what's a verb, and like for different languages in different contexts. This was like linguistic studies. And then there's also other parts called named entity recognition, which is when you look at a document, you figure out, okay, this is an organization, this is a place, a geopolitical entity, this is a time, you have things like this. You can imagine all of this information would be very useful in the context of data science, right? If you could figure out what is a place or a thing based on just a word in a sentence. And then you also have things like dependency parsing, which is basically you looking at a sentence and you're just parsing the way the sentence is. So you have subject, object, and you can verbs, and you can figure out how a sentence is structured. You can get intent if someone's asking a question and you're not sure with just a question mark at the end of it if that's missing. Understanding intent is also, so you can do all of these things using computational linguistics, right? Now, the really cool part is there's a Python package called Spacy, which I use a lot and I like to talk about, and I talk about this in my tutorials as well, which Spacy's S-P-A-C-Y, in case anyone's interested in doing a quick Google search for it or something. It's a really, really neat Python library which does a whole bunch of computational linguistic stuffs really, really fast and really neat. It's industry grade, and I'm going to give you, like normally when I actually had this slide up before, someone's like, yo, why don't you show some code? And I keep saying, you can use 5 lines of code to find some really cool stuff, so I thought I'd actually put down 5 lines of code. There it is. Cool. So this is code in my talk. Yay. So you have adjectives is, okay, it's easier for me to look at it over here. So you have adjectives as a list, and then, oh, just some context here. HP is basically the first Harry Potter book. And I've run this through the Spacy pipeline. This is very easy to do. I'll be showing you the other code for that later. So you can basically run any kind of document you want with these Spacy pipelines. And I talked about computational linguistics, how you can find parts of speech and named entities. Here, I wanted to basically check what kind of adjectives were used to talk about Harry. So in this context, so I just basically did for each sentence in all the sentences in Harry Potter, for word in sentence, if that word is in that sentence, if Harry is that word, then for that particular word, can I find all, for child and word.children, means when I'm looking at my dependency parsed sentence as Harry, if all the words associated with Harry, if any of them are adjectives, .pos underscore is dot part of speech. So if the part of speech of every word which is associated with the word Harry is an adjective, add that to my list, which is empty or on top, and then in the end I just count that, and I get the most common 10 words. So this is an example of 5 lines of code to do some really neat computational linguistic stuff. Now, of course, you can go on and do a whole bunch of things. This is also kind of pseudocode. It works with some changes, but it's a bit of a pain to do, so I'm not actually running it. But this is more to give you an example of the kind of things you can do. And I think this is very, very neat. So this is not even complex machine learning stuff, is it now? It's just basic text analysis. Now, of course, the way these part-of-speech tags were found out was using a deep neural network model, which is always there. But it's still basic text analysis, and I think this is very, very neat. So now, this is my slide where I tell myself I have to kind of sum up-ish. So the whole point of this was to kind of give you an overview into the kind of things you can do with textual analysis. Things have got even more intense, by the way. There are some things which you might not find particularly useful, but are really, really cool. One of these things which I really like to talk about is something called recurrent neural networks. Recurrent neural networks are a class of neural networks. Neural networks are a class of machine learning algorithms which are loosely modeled after the biological brain in terms of neurons and their interconnections is where they conduct mathematical operations as these links. This is a very overview of what they are. If you're interested, I would really recommend reading about it more. But neural networks are these class of machine learning algorithms, and recurrent neural networks are one class of neural networks. And these tend to be really, really neat for textual analysis. The reason is because they can understand, they have memory capacity, so to say. So there's a class of a recurrent neural network called an LSTM, or long short-term memory, and what this means is that it kind of tends to remember, the context of words, which would just mean what words are around it. And how does it use this information of what words are around? It attempts to predict. Now, we have 2 kinds of models which we can use. One is what you call a character level neural network, and one is what you call the word level neural network. So basically what's happening is, say you have a single character, you can try and predict what are the odds of a character coming up after that, which is most likely to make sense. So for example, if you feed into this neural network a whole bunch of Shakespeare, right? Or a whole bunch of anything, actually, it'll start to learn to reproduce that style of that whatever text you fed in. How does it do this? It figures out, so for example, if the word is thou, you just start with a random seed of thou in a Shakespeare, and you probably have hast or some 1500s word coming up after that, right? Now, how does it know this? It looks at what are the odds of certain words appearing after thou based on what's already been written, and it has a probabilistic model, which is very clever, right, because of the neural networks and the way the interlinking happens, and it allows you to kind of reproduce other styles of text. And this is not just, there's a really, really nice blog post which I enjoy by Andrew Karpathy called The Unreasonable Effectiveness of Recurrent Neural Networks, where he actually talks about all of the cool things you can do. He actually fed the entire Linux code base into a recurrent neural network, and it was writing code. So you have a machine learning algorithm which is writing like syntactically correct code on its own. It could write LaTeX sheets, which had to be corrected because LaTeX is a pain in the... But point being, it was really, really cool. You could do a whole bunch of really... Now, what are the possible uses of this? Right now, it's kind of iffy because it doesn't really make sense, right? It's just generating text. But it has a lot of potential in trying to generate text for like chatbots or conversations. It's also called a neural conversational model. There's a whole bunch of really... Potentially right now, we're not sure how exactly can this be useful. But there's a lot of really cool things just to explore over here. And the best part is, and this is my absolute favorite part, it's you don't have to be a researcher to do any of this stuff. There are a lot of tutorials out there where they tell you literally step by step, this is how you do it, and you just need to do import keys and a bunch of other stuff, and that's it. And it's absurdly easy to do all of this on your own. So the learning curve, I mean, if you're just going to be using the packages and you have some kind of intuition to what's going on, you can start doing this right away, and I think that's the best part about all of this. Python remains a very good ecosystem for this. The data is easily available. There's a lot of interesting questions you can try to solve. There's also a lot of jobs in this particular field. So I think it's a very useful skill to start at least having a look at or starting to read about or be interested about, and then you can get on more into it and figure out if you really want to continue. But that is pretty much the motivation behind this talk, to introduce you all to this world of possibilities, this world of things you can do. Now, I realize that there's not been much code or talk of libraries or actual things, so I'm going to remedy that very briefly. So like I mentioned before during my talk, I have done a text analysis tutorial just yesterday, and the video will be up. So what I do is whatever I've talked about, a bunch of the things like topic models, text classification, part of speech and computational linguistics, and text generation. I cover all of these topics in this tutorial very briefly, just trying to introduce everyone to it in a simple way. So if any of these things even sounded remotely interesting, I would really recommend having a look at my tutorial where I have a lot of other links where if you want to get into more detail, you can check it out yourself. So I think as a starting point where like you're not sure if you're interested, but you want to check it out, you could have a look at my tutorial. How you'd find it, you could, this is my Twitter handle where I usually only tweet about Python-related stuff. I have one cat picture. She was like on my laptop while I was writing code, so it's kind of code-related, right? But I do have that. But apart from that, it's usually just a bunch of nerdy stuff. You can check this out, where I will also be, right afterwards, I will be tweeting my tutorial, like all the code to it, the GitHub repository, so you can check it out. So you might, if you are interested, you can follow me on Twitter. You can also follow me on Instagram if you'd like. Lots more cat pictures there, though. I hold no code promises. But so this is my social media / work. My email is also bhargavvader@gmail.com. It is also my GitHub handle. So I am pretty easy to find on the internet if you want to contact me or talk to me more about text analysis, if you want resources on where to start, or anything in this general, I'm fairly friendly. So please reach out to me. I would love to talk more. Also, I have written a book about all of this. It's called Natural Language Processing and Computational Linguistics. It's published by Pact Publishing House. So what it does is all the things I've talked about, I talk about in more detail with a lot more code, examples, resources. So if you are interested, you can check it out. A lot of my Jupyter notebooks and the things, my code and all of these stuff are online on GitHub as well. But if you would like to buy the book, that would be totally cool. And I'd also, if you want the link, and I'd probably tweet about it, or I have tweeted about it, so you can find it. And I believe that's it. Well, yeah, that's it. Thank you very much. Are there any questions? Want to give the mic over there, or?
Does your tutorial discuss visualization of
visualization
of these types of results, or would you describe any resources to go for primers about that?
Sure. So the question is about visualization, and that's a very, very good question. Because that's a huge part of any kind of analysis in general, right? Now, to answer your question, this particular tutorial, which you'd find doesn't, but on the same repository, I have a topic modeling tutorial where I have a lot of visualizations. I also have an entire chapter on my book if you'd want more visualizations. But that being said, the internet's always a good resource, and it depends on the kind of visualization you want to do. I work mostly with topic models, or what I'm pretty good at, so I know a lot of resources for topic models. GenSim would be a PyLDA-Viz is a Python package which does LDA visualizations. Of course, you'd have Seaborn, Matplotlib, all those you'd have tutorials which talk about that. But specifically for text, you have word bubbles. Those are super popular. And there's a Python package for word bubbles as well. Otherwise, I would recommend GenSim. If you just search up GenSim visualizations, they have a visualization for TSNE, which is a way of doing clustering. They have using text as well. They have visualization for topic models, for word-to-vec, for classification. GenSim is what I would recommend. Also, they have visualizations for training these processes. You can see how well it's being trained. So I would recommend searching up GenSim visualizations. This is what I'm aware of. I'm sure there's a whole bunch of other stuff out there. But this is what I would definitely know about visualizations in general.
What's the major class of problems that you've encountered, things that bug you on like a day-to-day basis while you're doing text analysis, and what kind of efforts are you aware of that exist to solve those problems?
Sure. So the question is about what kind of problems bug me on a day-to-day basis with text analysis and what are possible ways to deal with this. So unfortunately, I mean, I get actually asked, it's interesting that you asked this question because most times when I'm encountered these problems are actually at conferences when I give a talk or a tutorial, when people come up to me and they tell me about their problems and they ask me how to solve them. The reason I'm mentioning this is because I've been working in research for pretty much most of my life. This means that I don't usually, and I'm not very, and there are also Python packages I'm contributing to and developing to, so I don't work with many text analysis projects or problems. I'm usually working on the tools behind making them, which means that I'm actually not, so there are some things I am aware of, which would be actually from talking to people who worked on this, and the most commonplace is dirty data, where data is just not, so annotation is probably the biggest deal. So annotation is classification or labeling, and in most cases, this is the biggest problem because the more useful text analysis algorithms are classification or supervised, right? And this is usually a problem because annotation is not done well. There is a Python package. I talked about Spacey earlier on, which is also a lot in my tutorial. They have this annotation tool called Prodigy. Prodigy is awesome. I totally dig it. Spacey in general has a lot of really useful tools. Prodigy is very good for solving annotation problems because I would argue that annotation is probably the biggest problem. Dirty data, the fact that, because a lot of times people are the ones doing this, which is totally cool. I mean, people are cool, right? But the thing is, it doesn't always work out well, depending on how well people are paid to do this or the tools. Sometimes it's just on Excel, and it's not always neat. So I think just the fact, and this is not just text analysis, right? This is all data analysis. You have problems with annotation. You have problems with, but in the context of text analysis, Prodigy is a very good tool to solve annotation, which is a big problem. Apart from that, I think apart from English, not many languages are supported as well. I spent the last 2.5 years in France, so I would talk to, and I was traveling a lot in Europe, doing these conferences and talking about this, and it would be cool because I would depending on the country, people would have different problems based on their language. So they would come and say that, hey, in French, there's like a whole bunch of models, but in Spanish, so it's not, right? And that's kind of linked to market size, right? So it depends on that. I mean, I was at PyCon Lithuania, and they were like, there's no really good Lithuanian language models. And I'm like, I'm sorry about that. It's just a problem, right? So you have things like this where particular niche problems for certain languages, it becomes more difficult to deal with particular cases. But the problems seem to be more or less the same, annotation being the biggest problem. Also knowing, I think in general when you expect machine learning to solve a problem, being very clear about the expectations of what you can solve and what you are getting, because a lot of times when I'm consulting or talking to people, it's from people who are outside the realm of data science. So they would say, this sounds like it's a problem which can be solved, and you look at it and you're like, no, not really. So I think being a bit, not getting ahead of yourself when you're looking at a problem and seeing whether text analysis is actually a way to do this is a huge part. So, I know this is not a very concrete answer, but I would say just kind of be careful about know the extent of the problems. Like topic models are not going to find you some kind of hidden magical topics. What it's good at is finding a large overview of the texts you have, right? So knowing what kind of things to use, it's very generic, but I've noticed that most of the problems are related to this. Bad annotation or data, not knowing what kind of problems you can solve. And if you're working with more obscure languages, then it's going to be just difficult getting the data for this. Like Word2Vec, which I talked about before, they have excellent models for English, not so excellent for other languages. So you have these problems. If you're working only in English, and scalability is also a problem. But again, any data analysis problem has a scalability problem. So I suppose these are general good points to look at, but maybe we can talk in more detail. I can tell you more details about what other people I know who've done text analysis, what problems they have. Personally, I've not faced too many because I'm working on the research side of things, so things are a bit different, but I suppose this would be general advice. Anybody else? Yeah?
How do you deal with spelling mistakes?
Oh, this is a good one. So spelling mistakes. Now, there's actually, so this, I wouldn't think of it as the whole, just really practically, I'll give you some examples. I had to actually, this is good because this is kind of linked now. And spelling mistakes is actually a problem which does come up. So I was once working with this really massive data set of academic researchers. It's called a Microsoft Academic Graph. And what happens is it basically tells you who's collaborated with who and how they've collaborated. And there was a huge bunch of text analysis involved in this because of people's names. And I was trying to figure out how people misspell things like this, and names can be complicated. One way is something just called like word diff. So you just look at, you just check how close it is. So you have word similarity not based on context. But now this becomes really difficult if you have a 3-letter word, which is misspelled, right? Because you'd have like 66% similar, and it's just kind of difficult to deal with this. Now, if the word's massive, it becomes easier to deal with these kind of spelling mistakes because you'd look at how similar it is. You'd say, oh, this word is not in your vocabulary. So you'd have vocabulary. So like normally when you start a text analysis project with a large body of text, you count all the unique words being used in that body of text. So yesterday in the tutorial I was doing, after all the data cleaning of 300 Australian newspaper articles, there were 5,400 unique words, which is really small, by the way. But this was after a lot of pre-processing on a small data set. But you have vocabularies. And in your vocabularies, one way you can do is you can actually match this with existing vocabularies. You can check how many are not in vocabularies, look at words and like manually sort them. This is one way you can do it, which is more time consuming. That is, so you look at, you know what words are spelled correctly, you check which ones are, so you'd have to do a double check over here. Another way, if some things are like word diff, which I talked about, there's a library called, I think difflib or something like that, or which basically does this, or it uses Levenstein distance, which to basically find out, this is basically just checking how close a word is to another word. So these are ways you can find commonly misspelled words. So there's a bunch of ways. There's no real 100% answer because that's a human mistake, so to say. I mean, it is a human mistake. And I mean, of course, computers can make the same mistakes, but the nature of the error is human. And these are 2 ways I can think of in the top of my head to deal with this. So I worked using both. I think it's called difflib is what I'm thinking right now is the name of this library. So this is how I would look for commonly misspelled words and try to figure it out. But it's just annoying at the end of the day. I mean, you just kind of have to deal with it, more or less.
Can you talk a little bit about like R versus Python and what anything Python can do right now that R can't?
Oh, okay. So the question, sure. So the question is about Python versus R. So the thing is, I'm really a Python guy. Like I've been using Python pretty much all my life, and I can code in R, like gun against my head, I will do it, but I haven't done it enough for me to be able to answer your question very well. I do know they do have some topic models for sure, and they would have text classification. But in my experience, and I have done brief topic modeling using R because there was a neat implementation of topic models in R, which is why I checked it out. But I found, maybe it's also because just of the fact the amount of time I've spent using Python, but I found text scraping, like for example, opening text files, loading text files into files, and then all of that I found a lot easier in Python, just in terms of your text manipulation, because I think it's just very easy to manipulate just text strings, like strings. String manipulation is really easy in Python. It could be easy in R. In fact, if there's anybody else in the audience who've actually used R for text analysis, as unlikely as it may be, it would be cool to have someone weigh in on this. Because I would just say that I've not used R enough. I do know they have some class of machine learning models which are okay to do it, but I've not used it enough. And when it comes to just scripting as a language, Python is better than R. That I can say quite objectively-ish. So it's what I would like to say. If anyone likes to weigh in on this.
Yeah, so I've done a lot of text analysis, not a lot, I've done some text analysis in R, and it's the pre-processing that's really
right?
a lot easier
I
in
think so,
Python.
yeah.
And I can't speak to the full class of available models out there, right, in each language, but the pre-processing is just so much easier in Python. Yeah, so that could change things, and things like Stringer, being developed actively. I'm sure that's on its way to being changed. Yeah, that's my experience. And I'm an art guy, so
I saw a couple of hands go up over here in case someone, yeah?
Hi.
Hey.
Can you give us a sense of when you're starting with a problem, you're in an unsupervised scenario, you don't really know what exactly you should be doing. Do you have a set of steps that you take to kind of give structure to the set of documents that you have, or to try to kind of explore what direction should I go in with this corpus if you are not really sure how to proceed there?
Sure. So the question is, if you have a whole bunch of unstructured textual data, what are the rough kind of pipeline or steps you would do to understand this data set a little bit better? I actually, this is a good question. I'm going to say the same thing I've said a lot of times in this talk, which is topic models. That could be because I probably overuse them a little bit. But when it comes to an unsupervised method of trying to find some kind of latent information in text, that is the literal purpose of topic models. So I talk about these a lot on my GitHub repository. So what I normally do when I look at like some kind of, I would first run using Spacey. I would try and build my corpus. I would get rid of punctuation, stop words. So stop words are words which are not usually very useful information in text. I talk about it more in my tutorial if everyone else is interested, but I try to get rid of stop words. I lemmatize, get rid of numbers, and then I run topic modeling. This is what I do. And then I look at, like, say, for 5 topics. Then I say, oh, this is the rough breakup of my corpus. It, again, largely depends on the size of your corpus, right? I mean, if it's really, really big, I would be a bit more liberal and say 40 or 50 topics, and then manually inspect these topics very briefly, and they give you a really good idea. Like, for example, the newspaper example I gave before, if you don't know the context from the Australian newspaper dataset I use, you can find the context, like, really fast. Like, you can just look at these topic models after you've cleaned, like, wow, this is what it's about. And then after that, based on your problem, you'd get more into it. Now, that being said, topic models are kind of outdated. The original paper by David Blay, who came up with the first topic model for text, came out in 2003. And he's actually been actively doing work on this. He's over at Columbia, I believe, right now. And he's doing a lot of cool work on topic models to keep it more relevant, more robust. There's also something called TSNE, which is used for clustering. And I believe it's been used for words quite well as well. I think that's a cool way of doing it. And that's a visual way of doing it. So if you want to get some visual thing going on over there, it's pretty cool. But I personally think if it's unstructured, completely unstructured, topic models will tell you, say there are 5 topics, it'll basically break up every document into one of these 5 topics, a combination of them. So for example, if you had this really bizarre article about, I don't know, the day Hillary Clinton went to the beach and it was really rainy and she played soccer, this should be like 30% politics, 30% sports, 30% weather, possibly, based on the breakup of words. But this still gives you some kind of useful information, right? Like what kind of documents are appearing in my really massive corpus, that all of the articles in my massive corpus would probably be in one of these 5 topics. So this gives you a good overview, and then based on this, you can throw more sophisticated things at it, like word2vec or whatever, based on the kind of problem you want to solve, right? Or if it's just annotation or whatever. So I would think that this is a kind of a good way to start dealing with unstructured data, which is clean it, and after you kind of get it a little clean, run a topic model, re-clean it, and keep doing this process until you get as useful information as you can, and then get into the more fancier things. This is what I normally do, and I think it works fairly well. But in most cases, you usually have a very clear business problem on what you want to do, and based on that, you would work differently. Usually, like I talked about annotation before, remember, that ends up being the most important part. I think annotating, and Prodigy, which I talked about before, is a very cool tool. You have to pay for it. It's a software which you buy. The same folks who made Prodigy are the creators of Spacey, which is an open source Python library, which is very, very cool. And they also do Displacey and a bunch of other things. Basically, there's a lot of really cool tools you can use to get an idea of your data. But after that, it's kind of up to you based on your particular problem, I suppose.
All right, thank you, Bhargav. That was a wonderful talk. Let's give him a round of applause.